So
What?
stream is now audible for everybody. Hi, I'm gonna work on the stat cache today. I'm making
It's
a block
not
diagram for it.
audible.
You,
Wait,
your
can you
voice
only
is
do
here.
lowercase?
Yes, it's only
Yeah.
lowercase. Oh, you submitted it. It liked it. It took your name because immediately as soon as you hit enter, it went D dot dot dot.
Holy shit, I got it.
Hey.
Holy crap! It wasn't stolen.
No fucking way.
Holy
Shit.
Matt, you got your name?
Whoa, what the fuck?
hell?
Oh my god. How is that not
Hey.
taken?
Dude, you were an OG. They liked you enough, apparently.
Holy
You're also
shit.
Nitro. I was just saying there's
I-
no way you're gonna get that name too.
That is so funny.
Everyone got their name but you. I'm sorry.
What was Maddie's name?
It was just Maddie. There's
Look,
no
there's
way
such
she was
a-
gonna get that.
Yeah,
Absolutely
Totally
no.
could have got it.
Unless she was on Nitro since the beginning, there's no fucking way.
No, I lost my active developer badge.
Oh, you did?
Why?
They remove it. They only give it to people who maintain a bot that's in a server, a special type of server. I forget what it's called, a community server, I think. Where when you have that enabled, then they can like see into your server and like it's like a public community thing instead of just like a private server for friends. Yeah.
Okay, so
I mean,
Yeah.
isn't L1 Cache a community server?
No, I made it a community server for like a day to get the badge, and then I turned it off because I didn't want Discord scanning everything.
so you have a registered
More so than they already are.
Mm.
I like to watch videos of sovereign citizens getting fucking wrecked by judges.
Okay. Why is that pertinent to a stream? I'm about to go on like design talk, by the way. Soon.
I'm just gonna bring up all kinds of stupid shit while you're...
I'm just gonna ban you from the server.
You wouldn't. I would cry.
That doesn't stop me.
I would
I
cry
banned Dylan in a
so
heartbeat.
hard.
Dylan was
I would
banned from here
cry
for like a week.
So hard. But I'm not Dylan, though. Better than Dylan.
That's fine. Okay, so a stat cache line will need these when it's in the stat cache. Each entry will actually need its own state machine. Just kind of blah, but I mean, the speed up it gives you is so great. It's just big. So then we'll have, let me group this. The hell? Why was that one not selected? Okay, there you go. So we have a stat cache where each line has that. As these, because we'll need, that'll aid us in somewhat, in like half-ass renaming, but not really renaming. So the stat cache will have 4 lines. What? Like, so weird. Why is it doing that? Oh, I'm dragging the wrong one. I'm getting weird. Okay, so the stack cache itself will have the idea is that the stack cache will have range in the back. Current SP. Contains okay, so the idea contains FP plus 8. Okay. Okay, so this is the idea, is that you have the stack cache has 4 lines contained in it, and these lines are the current stack pointer you're using is in one of these current cache lines, and the system tries to always make sure that out of the 4 cache lines you currently have up the 8 values in front of you and the 8 values ahead of where you are at all times. So no matter where you are in here, it's just going to make sure it grabs, since each line has 8 values, it just makes sure if you're on the line that contains address 17, it'll just add 8 and grab that next line, and subtract 8 and grab the line prior. So no matter if you push or pop in your stack a lot, you're pretty much fine. And then as soon as you enter, like at one of the plus 8 or the minus 8 ranges, it then will fetch the plus or minus 16. So the idea is that if you just keep marching forward, like if you keep going forward this way in your stack, you keep going, keep push. This would be able to detect, oh, you crossed this boundary between here to here, between the current and the plus 8. So it would automatically fetch the next 16, then which would mark this pending eviction. And you can just keep prefetching as you go, since cache behavior is pretty rather predictable, rather linear. So the idea is we have these cache lines, and in the cache itself, the tricky part about this, since we have the run ahead out of order stuff, we're gonna need to not only be able to stall on a like the same to be written stall that we have for the registers, but we need to keep all the other states for them as well. So there needs to be a thinking. In the stack cache, to manage these things, we'll need to have the current stack pointer. We'll need to know the growth direction. It's just because you can configure if your stack grows up or down. You need to be able to upper bounds, background. Lower. Okay, so those are the stats you need to track for the stack as a whole. And then each line needs to have a needs to be a. I just want to rig it. Yeah, this is it. All values clean. Oh, all states clean. That's a flag that says can only evict all states clean. Okay, so you can only evict a line when all states are clean. That's the limiting factor in eviction. Otherwise, you'll get coherency and consistency issues, and it's just going to be a whole bunch of nonsense. So before I was talking about needing an entire like way to track like pending reads and pending writes and stuff to these stack lines. If I load up the code, yeah, I have a write tag tracking and stuff like that. There was like rollbacks and stuff like that. Oh yeah, forgot there's speculation. Means that was just dumb. I should have just adjusted them, then copied them. Sometimes I really need to think ahead when using this. Oh, I thought those were all in a group. Speculative. I forgot to include the speculative condition in these state machines. Speculative. Oh my god, I just want these to be aligned. I forgot to include um mm. Okay, there we go. Now I'm gonna copy this here. Yeah. Now it's actually because they do have speculation bits on them. But like like I just forgot to accommodate for it. Like it's somewhere else. It's just not in this primary state machine. But now at least it's there. Yeah, we have all states clean. So we need, oh yeah, as I was saying before I got distracted. For this, we're talking about needing like write tracking and stuff like that, so we know if we're having issues. However, since we have the state machines on each value, we don't need to worry about that. Because if we try to write to a value that we can't write to, the states will tell us. So, so we don't even need any of that. All we have to do is whenever we issue out a write that goes to the stack, we just have to send out the location in the physical address. So since there's 32 entries in here, we just have to send out the exact entry of the that value will be writing back to, just that way it can be exactly where in here, because the stack pointer couldn't move in between that instruction and when it writes back. It's kind of renaming, but it's not really. It's just grabbing the physical address of where the stack pointer is and using using the physical address. Yeah, those state machines actually, even though they add a few more bits of state to each one of these, the whole idea of needing that like write queue and all that stuff was going to be way too much. That actually simplifies this a lot. Okay, so then all I really need to do is write a cache line. If I just build the cache, build these up, build an entry. I'm gonna break this up even further. Okay. Okay, so I feel like this is all all the notes we need should be. That's a very, very loaded comment to make. Hello.
Hey, hey.
I'm getting my trigger finger's getting fast at that.
Oh yeah, nice move.
So yeah, you remember the state machine we were working on?
Yes.
So I mean, last time YOLO was here with us on Friday, so I didn't get any progress done on the stack, but I went over the whole system and went with him like 4 times and how it compared to traditional run ahead, the scoreboarding in pORC1 and Tomasulo's and all those. But it allowed me like work through a bunch of random like things that I thought about in my head. And on that note, I was able to like think through the actual like stat cache much clearer. And with, you know how we were talking about doing all that metadata tracking and stuff like that and doing like the right we were gonna do like a right tracking and all those things. It was gonna be very cumbersome.
Yeah.
Since we have this really nice state machine, it's the same way. No, but since we have that state machine all clean and everything like that, and I added the speculative state to it, which is it's a state we've always had. I just didn't have it in the state machine, so I put it here as its sort of like separate thingy. But when I was thinking through the stat cache, we don't need to do any of that if we're sending the raw, and since we have each cache line has 8 values and there's 4 cache lines, that leaves 32 entries are going to be active at any time. If we just send out that 32-bit value and then modify the state machine accordingly, the same way that we would a normal CPU operation, then we know that we're golden. And if you do try to like, if you move around the stack a bunch, then you try to go, if you push like load a bunch of things into the stack, and then you try to like modify the stack value again, like pop, and you get to that loaded value and it's not ready yet. Since it's kept track of in that line, you're gonna go read that line and it's gonna be like, oh, sorry, it's not ready, and it's gonna throw your instruction to the run ahead queue.
Okay.
So it allows you to use the stack like as a super out of order like system. Yeah, I'm excited for it.
Oh yeah. I'm looking at the YouTube stream. I'm behind, I guess.
Yeah, I can stream in here.
You were talking and I was looking at your cursor moving on the stream.
There you go.
Sweet.
I don't like that color, but I just want them to be distinguished. Better. That looks much better. And it makes this diagram even more friendly for my remarkable, which I'm going to change these to blue colors.
Get a new remarkable?
No. I just like whenever I make documents, I like making them so that way they go well and they display nicely on it.
Mm-hmm.
Oh, yeah, this isn't a group yet. Group up. Okay, cool. Oh, these are supposed to be
Separate. An A. I always misspell separate. I know it's wrong.
If I spelled it, did I actually spell it right?
No.
I did not.
No.
Makes me sad.
I always make the same mistake.
What? How is it actually spelled?
S-E-P-A.
Oh, separate. Separate. Yeah, separate rather than separate. That looks so wrong, though. It looks so wrong. This is why I don't like spelling, because it just that hurts my head.
Also, it's it's a noun verb. 2 words really. It's act of separating and to say something is distinct.
Yeah, okay. But yeah, so all I really have to do is if I keep track of the current stack pointer and I just have a system that my current thing that I'll need to manage will be eviction tracking. This is the one thing that I'll need to like definitely work on. Yeah, so this will be this is the stat cache in clumsy diagram, but pretty much covers everything. So So I think my current thing will just be how do I want to go? I know I need to make a cache line, so I feel like that would be a good place to start. Yeah, so I'll make the entry and then stack the entry into a line and get an all clean flag. And then once I have that, which I'll have to think through how I want to do the addressing. I'll do the, I won't do the local addressing, so 32. So just like a 5-bit address. Yeah, so it'll take a 3-bit address in to say which one it's reading from, which one it's going to write to. I just realized something. This only needs to be single read, because if I have, since it's a stack pointer, right? If you use R14 as both operands, then it's going to be the same value twice. It's not going to give you 2 separate values. So this only ever needs to be a single read. Because this is a single register. This is only taking in, hey, you picked R14, and this is saying, oh, this is my current R14. Yeah. Yeah, that works. I only need a single read. Awesome. So then, yeah. Let's make a cache line. Okay, so I don't need this, but I will need to instantiate this one. Okay, so now I need line entry, module, parameter. I know there was a parameter. This one. Yeah. But I ended up not even doing the 0 register exception. Okay. Something fell. Your hard drive fell.
That doesn't sound good.
She had emergencies she had to attend to. 1 second, I'm responding to something on OR.
Lately you don't feel like yourself, and you kinda hate it. You suppress all of the thoughts in your head and say it's complicated. You hide your pain, but I can see it etched on your face. I know the feeling, swear you're okay, but you're barely breathing. Don't you walk away. 'Cause I feel you getting lost, I feel you trailing off. Feel it in your words when you say there's nothing wrong. There's something so subliminal about the way that your hands shake whenever you talk. You stare into space like you're lost in your thoughts. Tell me what's been going on.
Yes, I love how people are like, why am I writing the result value to memory on F? Why would that make sense? I'm like, you're just writing it to memory. It's just what I'm requiring. It's just a register value. You write there to be judged, just to show that you can write something to memory. I don't care. Like later on, you can think of that as writing it to a stack because you're returning from a function. So you're just writing to the value that was in like register B, which in this case is going to be F, but if you were managing a stack, would be your stack pointer. So input, you have write, enable, data bit width as well.
Tell me what's been going on.
Data bit width -1. And okay, with this state machine, we need to send in these kind of information. But this comes straight in anyway from this whole setup, so that's fine. This only has these two outputs. Yeah, so these will just be queuing right here.
What's been going on?
Okay, and then we need our registers currently have a speculation status. So need to go in there and look at the register files. So Oh yeah, it
Linting,
says,
really. It's saving you some time.
register cell. No, that's just gonna be data bit. What? This is going to be data bit with -1, and this.
You got an extra bit on top.
I know that extra bit's on top supposed to be there.
Oh yeah, I see that. So wires are supposed to be. Yeah, that's right.
Okay, I saved it again, and now this is. Oh yeah, shit. Yeah, I forgot. I need to. Okay, there you go. Now it's happy. Cool. I never added the end speculation condition. What the hell? Because this needs to clear. Or clock enable. And speculation pulse. Yeah, there you go. This register cell is going to be so similar to the thing. The only difference is that there's no write data. This is upper and not think reset, and this will be Why did I never add a reset condition to this? I'm just gonna delete this. So for the stat cache, we need an instance of this. Okay. Then data output 30 output and sending right. So yeah, I think I actually can use this exact register cell. I just add a proper reset condition, and then I just set the load enable to 0. So Smith prediction false, and this comes in the upper bit's going to be set. I don't want to OR this together. That'll add yet another thing in here. Let me copy this and then just like reset.
Only checking the top bit.
So I know I want to reset. So what I think, this is a write back enable that comes in. I could have a write back enable, load write enable. Oh, that works. Or sync reset. And not. So what this would give me is that this write back data will be when this upper bit is set. And then when the lower bit is set, this will be on. Oh, and then OR. And then this would be 0. And then this right here would then be the shadow. Oh wait, no. This would be the reset because it's an OR. And then the shadow right would be the default. So if you're not syncing, resetting, or writing here, that works. Now, oh, fuck. There we go. That's much better. And now, if I just set load write to 1, it's not gonna like, yeah, that works. Because this is gonna need a mux here anyway. It'll just optimize away this fourth condition in the logic gate. Cool. Which means I can then go into the register file. Let me validate that this is actually using the right cell. Speculating, we'll be writing to A, and speculation, misprediction. Write enable, write to, okay. Register cell of oh. Then we have this. Cool.
You have those inputs with the word pulse in it. What does that signify for you?
That it's a monostable. It's only going to go off for 1 cycle. And speculation pulse. Writing this is data in. This is going to be 0. Oh, this is just going to be 0. This is going to be a bit with 0. And read data is going that. Okay, cool. Yeah, I know you because you're in a different subdirectory. However, that looks solid. Everything's connected, and that's the entire cache line. Well, cache line entry. Now, I need to take this and write it into a cache line. which that does, it has the rollback, it has the value, it has the state machine, which it does because it has the state machine, and it has the cell, which has the rollback, and oh, speculating and then not data register data bit width. Yeah, so that way this only covers the first one, because if you write to this a second time, it's gonna overwrite the fucking shadow register, and it's gonna destroy the whole notion of writing back. So this only stores the value the first time, and then it clears it whenever you end speculation. And I like that we're using the cache, the register file cell and the state machine cell in here. Because if we have an issue in one place, it'll be everywhere. We can fix it quicker.
Everywhere.
Module. Two to 0. Read address. Yeah, I know signal's not used. Read address or enable data in is dirty. And get rid of these two. They're actually being used. Two. Right, and then line status will be output line all clear. Oh, that means in this state machine, I actually need to output when it's clean. Yeah. Sign is clean equals state 0. The state vector, I need to put a is clean. Then in this. State machine 30. Yeah. I'm gonna make it parameterizable, so it's not always gonna be 8. You can have it be anything you want. means there's going to be some variable bit widths in some places, but oh well, if you say, hey, I want to store 16 values in every cache line and hold 8 stack cache entries, you're like, well, your routing now sucks and you have a lot very slow speed, but you do you. I am going to take my obligatory 1 hour stretch break, and then I'll write this line and call it quits.
Okay, I gotta go find my cat. It was perfect timing.
Okay, I'll be back. I'm back.
Back. Getting my cat to the vet in a little bit.
Okay. 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 So. Write decoder. Read decoder. Okay. Then we need decoder. Line size. So then we have the two decoders. That cache line and So I'll need the write enable. I'll also need a read enable. Hmm. Dirty write and dirty issue. These get plugged into themselves. Doing from run ahead. Reading from is just the read enable. Okay, writing back and trigger state update and that trigger state update. Oh no, because I plugged in. Oh, I flip-flopped those. Because you're writing back, because you're actively doing the write back. Yeah, not writing to. Writing to will be like in the future. Writing to. Well, data in, I can data in, data out. Well, I will make a wire line size -1, fit width -1. Oh no, I just got a text saying my subscription for Netflix is on hold because there's an issue with some random ass dumb stuff that doesn't exist because it's a scam. I should be so worried.
A text message about that?
Yeah.
It's a weird scam.
Wire. All clean, check, equal. Or Line all clean. Not any not clean check. I like that. That sounds horrible, but I don't care. Wire. Line size is clean vector. Dirty. Let's be right.
Hello.
Hello.
Howdy. Morning.
Good morning.
Okay. Oh, I do need to actually. Read enable. Okay, so I just realized because I'll need a run ahead check index where it can read out. Because if the head of the run ahead queue is waiting on a stat cache, I'm gonna need to like have a secondary read that just checks out just that 30-bit. Assign is dirty, or that was run ahead check. Okay, and then now we have, now the run ahead can send in its own check. Because since I'm keeping track of like all these values and we have like these different lines, you could be like executing from here, but your run ahead queue could be like looking at this value waiting for it to come back. So it needs to be able to read this. Just the same way like you can read out of the register file and find its individual state. The only difference is that since when something's in the run ahead queue, you attach the stat cache like tag that it's going to be using. Like the index, the 5-bit address that goes to which 32-bit index you're going to be utilizing in the stat cache. So I can then scan I can subsample from the stat cache as a whole to grab what your actual status.
Yo, Gio, when you get the chance, can you check Slack?
Ellie, your mic is real low. Wait, maybe that's mine.
Hello.
That sounds better.
Alright, I just had to move it in front of my face.
I didn't hear what you said.
I was just asking him to check Slack real quick. Alright,
I responded.
Yeah, I saw. Thank you. I'm gonna be hopping off here for a bit.
Okay.
Okay.
Alright, so I'll talk to you guys later.
Yes, yeah. So this needs a wire, local read enable. Also need a local write enable, and I need a local valid. This will be I think instruction valid needs to just be passed. But how would I hold on? Oh yeah, I literally just sync that with the read address. This would be instruction valid and index. This is read enable and coded read. This is write enable write address. Okay, so then I think that covers it. Yeah, you get to, when you have a local write enable, it's just make sure that you're actually addressed to the right one. It sends these to the right things, and it hold on, let me look at the reading from. Does this trigger anything? Only when instruction valid is on. Cool, which means I actually don't actually go with a local read enable, and this can just be a read enable. Cool. Yeah, so now we just have an instruction valid that comes in. Uses a read address regardless of whether or not read enable is on. Yep. Okay. I like it. I like it a lot.
How much more complicated is the port list of stuff that you actually use for work compared to the pORC processor?
Sam?
Okay, interesting, because I'm using the pORC processor as like my bar of the feature set that it's using for like the Gen 1 of the tool. Can it successfully virtualize that? And that's what I'm shooting for.
If you can take my pORC1 and if you run that's good, great, and then because that uses like 99% of the same stuff, then if it can, then when pORC2 is done, if you can actively use pORC2, then it can run all of my shit.
Cool. The port lists in your stuff aren't actually that crazy complicated. The most complicated part about it is the parameters and the expressions where you do a little bit of math using those parameters on some of the things.
Yeah, like this.
Yeah, well, let me watch your stream. What's it?
Or have a line size equals 8, and then you have line address bit width equals line size. There's
Yeah,
a ternary operator, then it's the bit
exactly.
log 2. Yeah.
Like, I'm writing the section of the virtualizer that is dealing with that stuff right now. It's really interesting, actually. I'm gonna have to parse both the C++ header generated by Verilator and the Verilog file itself in order to get all the information required to do everything. And that is going to require like multiple passes and like holding temporary. I'm basically building like the very first stage of a compiler almost for.
Remember, I have that code from RSW that does a lot of that, does some of that stuff that we can always ask you. Like we can always pull up and reference if whenever it comes to parsing and stuff like that. Yeah, of that when you get to that point, get heavy into there.
What does that code do again?
It builds out the system Verilog project for you and like iterates through its hierarchy, goes through all the generate blocks and stuff like that, like pretty much synthesizes just the hierarchy, and then extracts every value in there. So every wire you instantiate, every register, every parameter, every value that could be sampled, it just lists it.
What do you mean just lists it?
It just provides you a large list, and then you can select, then provides you a huge list. Like it says, hey, this wire is in this top level / this module / write in counter write enable. And then if you send in with the second half of that tool, if you send in that entire like pointer to that pin, it'll then map that pin all the way up to a pin at that top level, so that way you can then do like debugging. That's something I
work?
Huh?
I need to look this up. I know Quartus has limits on how many pins you can have.
The pin limits for Quartus are equal to the pin limits of the FPGA you have selected.
Are there pin limits for Verilator?
No.
Yeah, there shouldn't be. Okay, so like,
because internal modules can sometimes have like thousands and thousands and thousands of pins. If you're dealing with a cache module that has like 5 or 6 ports to it, and they're all 256 bits. And then like some of those bits just broke up into bytes.
I don't know if this applies to some modules. I don't think it does, but any of the signals is, I guess, the technical term that they use to refer to all these different components. Any of the signals that are in the top level module that aren't in the port list, you can expose and manipulate them in Verilator by enabling this one additional header file to be generated, which is interesting. Although, depending on how that two-part program that RSW made, that sounds a lot more powerful. Or at least it's like half of it, because that could expose pins, and then the other thing can expose like signals within the module itself, not just the pins.
Yeah.
Interesting.
The reason I mentioned that is because whenever you're actually synthesizing something, the pins change based on parameters and stuff like that, and that's pretty straightforward. But when you start like synthesizing, like, well, no, because the part that I'm talking about is like if you have a generate block that has like takes one module and generates it 5 times, but that's all going to be handled in Yosis and stuff when that outputs its RTL image to you, the RTL graph file. So that's not even anything you have to worry about in this case. The only thing
Yosis is explicitly only really going to be used for visualizing stuff.
Well,
correct?
actually, you could take the net list, like the thing that lists all those connections. You could take that as a system and use that as a way that just generates all the potential values you could possibly store in your waveform viewer. But that also would just be, feel like you could grab that information potentially simpler from Yosis. Since you'll have all the states, you just index into there.
Like the state of all the pins and stuff like that. To populate that, I'm just gonna get it from the simulation. I'm just gonna pull it, get the name of the pins to do all that stuff. Like Yosis, my intention was only using that to just generate the loose, like, visual layout of the module.
I mean, that works.
And then I forget, I believe you guys also, this is very beginner stuff, the VCB file or the something dump file.
Yeah, the VCD, the waveform.
Yeah, you're probably gonna want that generated as well and populated.
Yeah, because that's what you're gonna view out for the waveform. Its waveform could just be an output of that live file of whatever it's currently showing for at least part of it. Wait, no, it can't be just that because we're gonna have like the manipulation points and stuff. We're gonna have those points in the.
Yeah, so we're gonna either have to. So I'll either, set up the method of just manipulating and writing to the file in real time, or have a temporary clone of it in memory, and then we'll write to it after you're done. You can download a copy of it if you want, or something like that.
By the way, I had 2 viewers for like 30-40 minutes as I was working on this, and then we started talking about this shit and immediately went to 0. Only
What was
because
the 0?
my 2 viewers left.
Dang.
Well, it's because I was actively like working on what I was showing, and now we're just kind of staring at the same screen talking about other stuff. But yeah, I'm very excited for all of that and all of this. I'm gonna call it here for the stream because I got the cache line made, and then next Friday I'll work on probably the eviction or state tracking. But yeah, this is actually gonna be much simpler than it's gonna be as simple as I originally was hoping, and I just overcomplicated it the last like 2 times we tried to review it in these streams because I didn't have this like state machine fully worked out. I would just assume that this, for some reason, the stack would need its own separate state system, separate from the registers, like a whole different mechanism, but doesn't actually. So yeah. I am going to call it here for the stream, and then next time we'll continue work on the stack cache. Bye, Streamy.
Bye.